Hello everyone. So welcome to this video on recursion. So what is recursion? Recursion is the process of repeating items in a similar way. In programming languages, if a program allows you to call a function inside the same function, then it is called a recursive call of the function. That is, recursive functions are very useful in solving mathematical problems such as calculating a factorial of a number, generating the Fibonacci sequence or the series. Also, you can use it to get the sum of natural numbers. All this you can do with recursion. So basically, a function that calls itself is known as a recursive function. And this process of calling itself is called a recursion. That is, any function that can call itself is called a recursive function, and the process of a function calling itself is known as recursion. So the recursion, or this is the process. So recursion continues until some condition is met. That is, looking at this diagram, recursion is going to keep running until it meets a condition like we have in the if and else. Okay, so when the condition fails, the recursion is going to stop. But if the condition does not fail, then the recursion runs continuously. So what are the use or the major use? Recursion can be used for breaking problems that can be broken down into smaller and repetitive problems. That is, recursion is used to solve problems that can be further broken down. So you have a problem, you have a function, a very big function that does something. You can use recursion to break it down into smaller parts that are becoming too repetitive. Also, the developer should be very careful with recursion because it is quite easy to slip into writing a function that does not terminate. And if it does not terminate, it's going to use an excess amount of memory or processor power. It could actually shut down your computer. So guys, without talking too much, let's code. So the very first example we use for our recursion is we are going to create a function or a program that adds up the sum of all natural numbers. So let me just put it up here. Okay, so it's a sum of all natural numbers. So natural numbers are from 1 to 9, but you know, you can create different modifications and have 1 to 100 and so forth. So let's do this. So the first thing we do, like we always do, is to include our header. Include standard input header. Then our main function, always int main. Then the return statement 0. Okay, so what we are trying to create here is a simple function, okay, that takes an input from the user, an input of any natural number, and it's going to sum it down to 0. All right, so if you give this program 3, what it's going to do for you is going to say 3 plus 2 plus 1, okay, and that is equal to 6. So let's create a program that can do this. So the very first thing is, let's create another function, and we'll call this function int sum. Okay, int sum, and it's going to take an integer of n. So what I've done here is I created the prototype. Remember, from function prototype, when you create the prototype here, it helps you to ensure that your program takes in the correct number of parameters before it runs. So I'm just going to copy this, then I can now create the function just below here. So this function is what is going to do the sum for us. But remember, in recursion, we say that a condition has to be met. If not, your program will keep running continuously. So let's say that if n is not equal to 0, that is, if n is not equal to 0, if it's greater than 0, then we should keep running the function. So we will say return n plus sum n minus 1. I'm going to explain this. Okay, if not, that is else, the program should stop, so it should return n. Now, what is happening here, if you look at this code properly, you will realize that this function that we have here, sum, is being called inside of itself. In short, let me put a comment up there. Okay, so I will say function sum is calling itself. So function sum is calling itself because when the function runs at first, when you have 3, it comes back again to check if n is not equal to 0, then n is going to become 2. All right, now let's go to our main function and complete this. So because we want to collect the user, we want to collect result from the person, we want to collect the number and send the person the results, let's create those variables. So int number and results. So let's ask a question by using a printf. So we say printf, please enter a positive number. Okay, then we use scanf. Remember scanf to collect user input. So we use scanf to collect it. So D, then we are collecting the number, the address of the number. So when we collect it, what do we want to do with it? We want to use it with the function. So we store the results, we store the result of the function call in a result. So we say sum number. Then we can print out the result. So we say printf sum is equal to D. So here we are printing out the result for the user. When you are done, you can see the result of what you've done. So a quick explanation again. Let me run this down. The first thing we did was this program is going to sum all natural numbers. So if you give it 3, it's going to say 3 plus 2 plus 1. If you give it 5, it's going to say 5 plus 4 plus 3 plus 2 plus 1. So the first thing we did was we created the function prototype int sum. Then inside of the int sum function, this is what we want to do. We always want to return n. So anytime it goes to 5, it should come back to, if we give it 5, it will go, it will sum 5 first, then come back for 4, come back for 3, come back for 2. So this is where we are doing the summing, and that is why the function is calling itself repeatedly. So this particular type is called the direct recursion function, okay, because this one is calling itself directly. Then now inside of our main, we are calling the function once. So since we call the function once, it is always going to come back here till this condition is met. Once n is no longer equal, once n becomes 0, it's going to return the final n, then the program comes to a stop. So let's test this out. So I'm going to run this. Okay, we have a problem with our code somewhere, so we have to fix that. Let me see what number that is. So in sum, okay, I can't seem to get the number where that's. Please enter a positive number. All right, so we have int number results printf, please enter a positive number. Okay, let me put a semicolon here. Then scanf, oh sorry, scanf. It's a scanf, not scan. So scanf %d number result is equal to number, correct? Then printf sum is equal to D. Results, yes, yes, yes. Okay, let's run this again. Let me clear my terminal. Let me bring it up a little. So I'm going to run the code. So now it's working. So it says enter a positive integer. So let's start with 3. As you can see, it says sum is 6. So what it has done is, for the first function call, it's accepted 3. Then it went into the sum. It said 3. It went back to 3 plus 2 and 3 plus 1. 3 plus 2 plus 1, and that's what gives us 6. If we run this again, and let's use 5, is 15. That is 5 plus 4 plus 3 plus 2 plus 1. Okay? So let's run it one last time. And let's use 10. So it says sum is 55. That is 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. So that is the recursiveness of the recursiveness of the function is working. It is going back in itself. It is calling itself to add the sum continuously till n becomes 0. Then the function stops. Then it prints out the results here. So that is that on solving or understanding recursive function. Okay, guys. So let's see something else. So guys, the next thing we should try out is what we call the Fibonacci series or the sequence. So what the Fibonacci series or sequence does is that it adds up the sum of the previous numbers. Okay, Fibonacci series. Okay, so in Fibonacci also works with a function or a recursive function because it is trying to add the number of the previous two numbers. So in Fibonacci, if we start with 0, 1, then 0 plus 1 is 1, then 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, dot, dot, dot. So you just keep adding. So 8 plus 5, you know. So let's create a Fibonacci program. So I'm going to delete everything we've done inside of our main function and also this function. So the first thing first is let's change this from sum to something like, let's use Fibo, a short form of Fibonacci. So this function is also Fibo. So take note now, we have two functions. The first one is our main function, and the second one is our function for the Fibonacci sequence that is going to do the recursive function or the repeated task. So what are we doing? First thing first, let's work with the Fibonacci function. So in the Fibonacci function, we want to create our if statement. Remember, you have to create a condition that must be true or false to ensure that your program or your function stops running. So if n is equal to 0, or let's just start with, okay, so if n is equal to 0, it should return 0, okay? Then else if n, so if n is equal to 1, okay? If n is equal to 1, then it should return 1. Then else, so this is where our main function, this is where our Fibonacci sequence is actually going to run properly. So it should return Fibo so it should return Fibo, let's put this in a bracket, Fibo n minus 1. So it's going to decrease the number as it keeps coming. So from 8 you get 4, you know. So it reduces the number itself. That is why it's recursive. It repeats the task, then it adds Fibo n minus 2. That's the formula for Fibonacci sequence. So that is why we have it here. So it should run if n is not equal to 0, and if n is equal to 0, it should return 0, and if n is equal to 1, it should return 1, else the sequence should run. That is because the program should always start with 0 and 1, alright? So that's why it's returning 0 and 1 for the first two if statements. Now, in our main function, what we need to do here is we need to set an integer n. I don't want to use scanf, so we can always change it. So we can say 8, then int I. So we're going to use a for loop. Okay, but before that, let's just print out a message. So we say Fibonacci sequence of D is and this will be n. So we want to print out that the Fibonacci sequence of maybe number 8 is this, okay? Then we proceed. So we create now our for loop. So for I is equal to 0, then our conditional is going to be as long as I is less than n, then we increment what? We increment I. So what are we going to do here? We are going to print out the numbers. So percentage, where is it? Percentage D. So what we are doing now is we are printing out the Fibonacci sequence of what we've gotten, okay, from the function. This is where we are calling the function now. So we call the Fibo function. So we say Fibo, then according to the increment of I. So let me explain what we are doing here. The first thing first is we created our function prototype int Fibo, okay, so that we can create the function just below. Then inside of the Fibonacci function, remember that the Fibonacci sequence always starts with 0 followed by 1. So we say if n is equal to 0, it should actually return 0. And if n is equal to 1, it should actually return 1. If not, then it should work with the Fibonacci formula, which is this. Then inside of our main function, where we are calling the function, we created an integer that is going to be the number of time we want the Fibonacci sequence to be outputted. Then we created an integer of I because we want to use it inside of our for loop. Then we created a message. So we print f Fibonacci sequence of percentage D is this. Alright. Then we created the for loop. Now it is inside of the for loop that we are now calling the Fibonacci function. So every time it calls the function, it goes back here. Then it checks this condition. If the condition is still true, it goes back till the condition does no longer exist and I cannot be incremented anymore. So let's test our code. So I'll pull this up, then I will run this. Oh, sorry guys, I used print somewhere. Yeah, this is it. So instead of printf, I use print. So let me clear this and redo it. So I'll clear this now, CLX. Then let me rerun this code. Okay, so you see it has run the Fibonacci sequence for 8 because we add 8 here. So if we do it together, remember what I was doing up here. So 0, 1, 2, 3, 4, 5, 6, 7. Then for 8, 8 plus 5 is 13. So it stopped right there. So if we change this to, let's say, 9, remember, because we didn't get to 8 because it has to be less than. So let me say 10. Then let's run it. So I've added 10. If we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So as long as it is less than n, then it started doing the Fibonacci sequence for us. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 8 is 13. 13 plus 8 is 21. 21 plus 13 is 34. Okay, so let's try it last with 20 and let's run it. So this is a very long Fibonacci sequence using 20. So basically, guys, this is how you work with recursive function in C programming language. So the function is going to keep calling itself repeatedly till this condition is met. Okay, so that's it, guys. We've just done 2 programs. The first one is sum of natural numbers, and the other one is this one right here, the Fibonacci series or sequence. So let's proceed. So recursion, advantages of recursion: the code becomes shorter and reduce unnecessary calling to the function. It is useful for solving formula-based problems and complex algorithms. It is useful in graph and tree transversal. Recursion also helps to divide the problem into sub-problems, which is very important and helps you to solve them. Okay, but the disadvantage is that the code can become very hard to understand and analyze, especially when it becomes big. And like we said before, a lot of memory is used to hold copies of recursive function. Remember, our function has to keep calling itself. So for every call it does, it stores these results in memory. So that is why it uses a lot of memory to work with the recursive function. Also, it increases the complexity because it increases the complexity of time and space, because as you keep working, you keep doing too much. Okay, you keep trying to expand on what you're doing, and that creates more problem for you if you don't understand recursion. And also, recursion is generally slow than iteration. So iteration is your for loop. That is to say, it is faster to use for loop than to be using iteration. Okay, so that is it, guys, on recursion in C programming language, and I will see you in the next video. Thank you.